So in this lesson, we'll be learning about opposites and absolute value. I can apply my understanding of integers on a number line in relation to 0 so that I can define and understand problems involving opposites and absolute values. I will know I've got it when I score an 85% or better on the assignment following the lesson. Okay, the first topic we're going to cover is opposites, and let's define opposites. Opposites are two numbers that are the same distance from 0, but are on different sides of 0. So an example would be 3 and -3. The 3 is positive 3. Just a little note, we don't put a positive symbol on the positive numbers. We just assume if there's no symbol to the left of a number, it is assumed to be positive. If we have a negative number, we put that negative sign, it looks like a minus sign, in front of that number. So looking at the number line, we can just visually see the definition happening before our eyes there on that number line below. You can see that 0 is in the center, and that when we go to -3, the distance from 0 is 3 units. We have to go 1, 2, 3 spaces to reach that from 0. And that would be to the left of the number line, on the number line. And then when we get to +3, we go 1, 2, 3 to the right to get to that 0, to get from 0 and to get to that +3. So it fits the definition. They are both 3 units from 0, but they are on different sides. -3 is to the left of 0 and +3 is to the right of 0. So they fit that definition for opposites. Sometimes our number lines run vertically, and so we have this vertical number line. 0 is right here at the center, and to get to +3, positive numbers on a number line are above 0 when they're vertical number lines, above 0, and negative numbers run below 0. So they are both 3 units from 0, but one of those numbers is above and one is below. So that also fits the definition of opposites. A non-example would be this. So sometimes students get confused, and I might have a question like -12 and 8. And ask you, are those opposites? And kids will say yes. And I'll say, why are they opposites? And they'll say, because one is negative and one is positive. You fit that they are on different, it fits this piece of the definition. They are on different sides of 0. However, they don't fit the other piece that is required to be considered an opposite. They also have to be the same distance from 0. And -12 is 12 units away from 0, and 8 is 8 units away from 0, so their distances don't match. So you don't confuse just having this opposite symbols, negative, positive, to define them as opposite values. Okay, in this next piece, we need to be able to read the symbol when we are given math problems. How do you read these symbols when you're given math problems? So we're going to start with some terms for the negative symbol. You guys are probably used to the term being minus, take away, subtract. Okay, so minus is a popular one when we see that negative symbol. Another popular term is just to use the word negative. And a third term that is very popular is the word opposite. We just talked about opposites. So there's another math term that comes in handy when we're translating these or trying to read these problems to understand. So if you see this right here, it can be read multiple ways. We can read this first example can be read as -3. It can also be read as -3. And it can be read as the opposite of 3. Whoops, I already got the 3 in there, don't I? Getting a little carried away. See if I can fix those. Got 2 3s. I'm going to scoot this over. So, no, I won't. There we go. So it's -3 -3, and the opposite of 3. When we have double signs sometimes, we have to learn how to translate that so it makes sense in our head. So we're going to translate when we're double negatives. How can we read that so it makes sense on how to simplify something when there's multiple negative symbols in front of it? So these are our choices right now for words that we can substitute in for those symbols. So someone might say this is -3. So the first negative symbol we translated as minus, and the second negative symbol in front of the 3 there inside the parentheses we called negative, -3. That is sometimes how it's translated. And another way we can translate this is to say it can be read as the opposite of. That's the first negative symbol. And then inside the parentheses, we would say -3, the opposite of -3. And finally, another way some students might think of it is the opposite of -3. The opposite of -3. So when you think of these, it's whatever your brain needs in the moment. So in the case of this problem, I would say the one that makes the most sense to translate this or to simplify this double negative is this one right, circle it here, is this one right here. Because the opposite of -3 is simply 3, +3. So depending on the situation you're in, sometimes it's a long math problem and you got to follow order of operations. Sometimes it's simply just given to you like this. Sometimes it's a multiplication or division problem. And you have to figure out what in your head is going to make the most sense to get it to where you need it to be. So again, if it's just sitting here like this, that's just 3, +3. So one thing too to note is anytime you're dealing in the positive negative world, we will, there's patterns to it. And it makes sense when we read those negative symbols. The opposite of any positive number is always going to be a negative number. And the opposite of any negative number is always going to be a positive number. So an example of what this sentence is saying, it would look like this mathematically. The opposite of +8 is simply the number, the integer -8. And the opposite of -8 is +8. So that's what this sentence translates into when we use it as math symbols. And I think you might see it a little clearer here, but that's what these are saying. Opposite of any positive number will be a negative number, and the opposite of any negative number will always be a positive number. All right, so the second piece in this lesson is the absolute value. And this is something we use quite a bit when we're making computations, when we have integers involved in our problems. And so it's important we understand what this is and when we're using it in our math. So to start with, let's just define absolute value. It's the distance a number is from 0 on a number line. It's a very simple concept. If you can figure out how far a number is from 0 on a number line, you have its absolute value. That's the term for that. So the math symbols that we use, it's key to understand what those look like as well. So when you see them, you know what you're being asked to figure out is these 2 straight bars. Okay, so we will have the 2 straight bars and then we'd have numbers inside them. Sometimes it's a math problem inside it. Sometimes it's just a number, an integer, or a number inside it. And we have to figure out what that's asking us to do. The key here is not to confuse your parentheses and your absolute value bars. Parentheses, remember, are curved. Absolute value bars are straight bars, straight up and down. The other thing you don't want to confuse it with is the bracket, which is also acts like a parenthesis with corners. Instead of being curved, it's going to have these corners. These are not the same thing, so don't confuse them. Absolute value is its own concept. So that's our example of what it would look like with the bar notation. Here's how you read this. So the first one right here reads the absolute value of -2. That's how you read when you see those symbols. You use the words absolute value. And the second one would read the absolute value of +2. This is how you think about it. Remember, absolute value is simply how far the number inside the absolute value bars, how far that number is from 0. So when you see those bars, here's what you need to ask yourself. You need to ask yourself the question, how far? Because it's distance. How far? How far is -2 from 0 on the number line? And then the second one, you would read, how far is +2 from 0 on the number line? And then once you have that, you just answer the question. How far is it? The answer to this is simply 2. It's 2 units. And the answer to how far is +2? It's also 2 units. So our distance is the positive version of the number inside the bars, because distance is a positive thing. So in this example, we're being asked 2 math problems. This is the first one. It says absolute value. Just recall, absolute value means how far from 0. It's a distance. It's distance. So how far is +5 from 0 on a number line? Well, when we're trying to figure that out, we simply have to count how many units. 1, 2, 3, 4, 5. It's 5 units from 0. So the answer is 5. And then we ask ourselves, how far is -5 from 0 on a number line? Well, that's this way. And it's 1, 2, 3, 4. It's also 5 units from 0. So the answer is 5. Remember, distance is always positive. So when we're finding the absolute value, we're finding the distance, and your answer will come out of these bars as a positive number. This one started positive and still came out positive. So this one was negative, but it comes out positive. So that's how the absolute value works. Okay, it's your turn to try these 4 examples. I want you to find the absolute value of -2, the absolute value of 4, the absolute value of -1.8, and the absolute value of 2/3. So pause the video. Write your answers on the lines, turn the video back on, and see if you understood absolute value. Remember, how far are these values from 0 on any given number line? So check your answers. You should have said that the absolute value of -2 is 2, because -2 is 2 units from 0. The absolute value of +4 is 4, because 4 is 4 units from 0 on a number line. The absolute value of -1.8 is 1.8, because -1.8 is 1.8 units from 0 on the number line. And the absolute value of +2/3 is 2/3, because +2/3 is 2/3 from 0 on the number line. So that is absolute value. All right, this next piece, I'm just going to amp it up a little bit and have us do some simplifying because using absolute value. So when you're looking at absolute value bars and you're thinking about what to do with them, it's actually a grouping symbol. Absolute value bars group things inside them. And when we see those grouping symbols, we have to make sure, if we're trying to simplify, that we do what's inside those symbols first. And then anything outside the absolute value bar would come next. So these problems below are actually 2-step problems. They have a lot of signs going on. They're a little bit confusing with all those symbols. Oh, I'm not being able to write very well here. They are 2 steps. Okay, so the first step is doing your absolute values. So this is GEMDAS. Your absolute value bars fall under the grouping symbol category in that memory trick for order of operations. And so we're going to take care of those grouping symbols first. So we have to do this right here first before we take this symbol on the outside. Okay, this symbol can be considered a minus, a negative, opposite, whatever you want to think of it as. But what comes inside is our absolute value first. So I'm going to look at this as it's the opposite of the absolute value of negative 10. That's how we read it. The opposite of the absolute value of negative 10. In order to take the absolute value of negative 10, I got to do that first. It's how far is 10 from 0 on a number line. I'm going to write down the answer to that piece of the problem. It's 10 units from 0. And then this symbol is next. So it's going to come down and it just reads negative 10. And you're done. This is its simplest form. So we cleaned this up by eliminating those absolute value bars because we could take the absolute value of the number inside. This next one, remember, we have to do absolute value bars first. What is the absolute value of 6? This problem reads the opposite of the absolute value of 6. Well, the absolute value of 6 is 6. So I take that. Now that's gone because I simplified it and I brought the minus down in front. Now this one reads the opposite of the absolute value of negative 2 3/4. Fractions, decimals, mixed numbers, it doesn't matter how absolute value still works the same. We just have to answer the question here to clean this up. If you get rid of those bars, we just answer the question, how far is negative 2 3/4 from 0 on a number line? And the answer is 2 3/4. And then our outside the absolute value bar, that's all cleaned up. This negative sign comes down in front. So that's how you would simplify problems that have absolute value in them and other operations going on as well. This is 2 steps because there were 2 things to do. First, you had to take the absolute value. Second, you had to take the opposite of that. So this is a 2-step problem, and we funneled it to show how things were working. Okay, and I just want to point out that sometimes we get confused when we have absolute value bars. We don't want to confuse them with parentheses. Absolute value bars, again, are those straight bars, and the parentheses are the curved bars. So when we're looking at this problem, it reads the opposite of the absolute value of negative 20. Well, the absolute value of negative 20 is 20. And the opposite of 20 is negative 20. This negative comes down and it's in its simplest form. Okay, this one reads the opposite of negative 20. Because it's parentheses, it's just separating these 2 negative symbols so it's not so confusing. And they do that a lot. They wouldn't write it like this most of the time. They'll put it in a grouping symbol to separate these 2 symbols just for making things easier to see. So the opposite of negative 20 is positive 20. Some people say the opposite of minus 20. Well, the opposite of minus 20 is plus 20, but for positive numbers, we don't put the plus sign in front, so it's just 20. So be careful to watch for those straight bars versus the parentheses. And that concludes the lesson over opposites and absolute value. Good luck.